Alright, I'm down here with my brother. He bought this here car. It's a 2004 Ford Victoria. It's got a 4.6 liter engine. And I'm pretty sure what we have is a fuel delivery issue. But right off the start with, we had an issue with the battery connections. And I didn't record it, but I'll go back and just show what we got from the beginning. Okay, if you do your check with the battery, you can see we got about 12.3 volts here. Now what we had was an issue between the battery posts and the connection. Now it was so bad that right now you can see that it's 0 volts. This was where the problem was at. We had like 10.5 volts, and that was not even turning it over to the start position. So we had 10.5 volts between the posts and the cable. So we took and cleaned all this up, and that was good. We came back over here and we checked, and this one here was actually good. So we didn't actually have to do nothing to it. And of course we did have it in the crank position, you know, far as in start, holding it and checking these here voltage drops across the battery posts and the battery cable. Now, as I mentioned, we got a fuel delivery issue. So what we did is we went ahead and just sprayed some carburetor cleaner into the intake. Engine cranked right up, ran for a few seconds. So now we're going to go to our next step. But just to show you, we're going to go ahead and do the carburetor cleaner thing just so you can see. So what I got is got some carburetor cleaner here. So I'm going to open the throttle valve up, and I'm just going to spray a little bit in there. Temporarily going to put the air intake tube on, and let's see if we get this thing to crank up. Oh. All right, looks like a fuel delivery issue to me. All right, well, let's take a look at this here fuel system electrical diagram. All right, where we start at? We got a central junction box. We got says it's in hot, in start or run. We're going through a fuse, 25 amp fuse. We're coming on down. We're going through this diode, this PCM power diode coming on down, and we see that we have this PCM power relay. Now we're energizing this here coil. You can see the other side of the coil goes directly to ground. All right, so now this is being energized. Magnetic field pulls in the contact. Now if we come back up to here, you can see that this is hot at all times. Goes to another fuse, 30 amps, comes all the way down, goes through the closed contact, comes on down, and then it's going to come off. Now these are two other circuits, but for our fuel system, it's going to come off and goes to E. All right, so now let's go to diagram 23-7. Going to 23-7, and we can see that here's where it comes in. Now you can see that we're coming into the fuel pump relay. We're coming into the coil for that relay. You can see the other side goes to ground. So now this coil is energized. That's going to pull in this contact. Here we see it's hot at all times on this fuse. Goes to a 20 amp fuse. Goes through the closed contact. Comes on down. Comes on down. Now we can see it goes through the inertial fuel shutoff switch. Comes on down. Goes to U. U comes up back over to here. So now we see we got U, which is coming in as a white wire. So what we're going to do is we're going to go to this here fuel pump module, and we're going to check to see if we have voltage, B+ voltage, here on this here module. And then the next check is we're going to be checking this here ground. So now let's go ahead and we'll make these two checks and verify that that voltage and the ground is there. Alright, so I've got, I back probed the white wire that I just mentioned earlier in the video. Now if I'm going to just take my voltmeter and I'm just going to touch right here. And by the way, we do have the ignition switch in the on position, so we can get the voltage back here. You see we got 12.25 volts. Now if I want to put a test light on there, you know, put a little bit more load on it, you can see that it glows pretty bright. And then if I want to touch it to see what kind of voltage we got, 12.22. So we know that wire is good. So now what I'm going to do is I'm going to use my test light to check the ground. So what I've done is I've just back probed, you know, you saw the white wire, that's our B+ wire, and the black wire is our ground. So all I'm doing is I'm just touching the ground. You can see the test light, it glows brightly, so we know our ground is good. Okay, now what we're going to be looking at now is these two wires here that's going all the way down to the fuel pump motor itself. Now if we look at this one, we see it's got a positive volts and then we got a negative volts. Now this positive volts should be on all the time. It should be B plus voltage. And we can see that's on the pink with a black tracer. Now with the ignition switch in the on position, that 12 volts should come all the way down. It should go through the armature windings, one of them, and then it's going to come back, and we should have 12 volts right here. That's what we're going to check. We're going to check this one first, then we're going to check this one. Then our next step is we're going to be monitoring this voltage right here, because this module is going to pull this here positive volts down to ground. Now if we just turn the switch from off to on, it should be about a 1 to maybe 2 second pulse that we're going to see. In other words, that voltage is just going to pull down to ground, and then it should go right back to 12 volts. And if we're cranking the engine over, then what's going to happen is that this here should stay at a ground level. So that's what we're going to be doing. Alright, let's see. We're looking at the positive wire going out to the fuel pump. That's the pink with the black. Alright, should be 12 volts, B plus voltage. We got the key in the on position, so we got 12.09. Now remember, as I said, it should go out to the fuel pump module, go through the armature winding, and then it should return back onto this negative wire. And what do we get? 0.092 volts. What does that mean?
Man.
We got a problem with the brush. One of the brushes in there is not making a good contact to return this 12 volts back. Now what we can do is we can go ahead and we can turn the switch off, then turn it back on, and then we can see momentarily if that will go back to ground. Alright, go ahead.
Right, on. On.
Okay, looks good. I saw it drop down, I think it was a 0.003, so that shows that this here module is trying to put a ground out there, but it can't return, you know, because we got a brush problem. So we pretty much need a fuel pump. Now we do have two other wires here. One is for the coming from the PCM. Actually both of them are coming from the PCM. One of these wires is going to be telling the fuel pump module, which is coming from the PCM, to tell it how much it wants to run this pump speed. So if the pump speed goes faster, you got higher fuel pump pressure. Goes lower, it'll be a lower fuel pump pressure. Now we also have a wire going back to the PCM. That's the feedback wire. So in other words, we want to know what is this here. The PCM wants to make sure that the fuel pump module is doing what it's supposed to do. So that's what we're doing there. So we know that those two wires are working because we are seeing our signals coming out here on the fuel pump wires, you know, the plus and the minus. But you know, to make this here a video complete, maybe we just might want to look at those signals so you can see what they look like. Okay, what we have is two waveforms, and the first one here in blue, this is the signal that's coming from the PCM to tell the fuel pump driver module what speed to run at. Now if we look at this one right here, we can see that it is well, let's go ahead and we'll check the voltage on this. We can see it's like a 5 volt signal. You see that's 4.92 volts on the peak, and then if we come down to the bottom, yeah, we're running around close to 16 millivolts. Okay, and if we want to go ahead and check the frequency, that's going to be, let's just grab this one right here, and let's grab it right where's our next one at? Right there, rising. And if we look down here, we're running around at about 146 hertz down here in the bottom. Okay, so that looks good to me. I'm assuming that's going to be normal. Now if we look at the other one here, let's go back. Now if we look at the other one here, you can see where we just turned the key on, right? We turned the key on. This one here in red is the feedback signal. So in other words, the computer is telling the module what speed it wants to run at. Then the module is going to send a signal back to verify, confirm, yes, the pump is doing what it's supposed to do. Well, I think this is where our issue is at, because if you look right here, you can see that we started out at 0 volts and we went right down here to maybe minus 4 volts. If we look right here, you can see that's about about 256 millivolts there, and then you can see it swinged all the way down to like minus 4.6 volts. Okay, well let's go to the next capture. So now you can see it stays that way. Then we come up again. Now you can see it jumped up. Now it jumped up to, let's see, what is it now? We can see that it peaked up at 6.6 volts and then it come down to 1.7 volts. So I'm thinking this is probably because it can't get a feedback from the from the fuel pump because it's not really running. So anyway, I say the signals are there. Maybe this feedback signal is not doing what it's supposed to. This one up here on the top looks like it's doing what it should do. And by the way, this one right here, it looks like it's running at a duty cycle of about, now remember we're controlling the ground side, so it has a duty cycle, I'd say it looks like about 30%. If you want to know how to do that, let's go ahead and check it. We're just eyeballing it right now. So let's just say I went from right there. I'm just going to check on just one of these pulses. This is the rising edge. I'm going to the rising edge of the next one. I'm looking, let's say right there. Let's do a measurement. This is going to be AC. I want to do the duty cycle. Now remember, this is going to be the duty cycle. When it's doing this, it's going to be looking at the top side. So maybe it's about 70, but remember we're looking at the bottom. So we'll take the 70. If it's around 70, we'll subtract it from 100 and it'll give us 30. Okay, and let's see. Between the rulers, let's see what we got. We're looking down here. Hey, I was pretty close. We got 73.5%. But you remember, that's up here on the top. So if we take 100, let's put a calculator up. Let me type in 100. 100 minus 73.54. And we got a duty cycle of 26.46%. Okay. All right. So we had to change the fuel pump, right? All right. And what a pain in the ass. That's the worst fuel pump I ever had to change as far as in clearance. You can't get to connectors. Engineers at Ford decided to put the connectors right up on top of a rail. You go on there and look on YouTube, you'll see them. And people cut the wires because they couldn't get the the connector to release. You can't get your hand in there. I mean, we got it'd be like 40 minutes to get a connector separated. Anyway, so we finally got the fuel pump in. Now when we got the fuel pump in, and now we do the prime, and of course now let me back up just a little bit. This car been sitting for probably about 10 years, and this thing had 3/4 a tank of gas in it. So we had to get all this gasoline out. So we got it all siphoned out. And we got the fuel pump changed, we changed the fuel filter, and then we put fresh gas back into it. And now we hear the fuel pump, you turn the switch on, it primes, okay, it's all hoo-ha. All right, so now we crank it and it does, it starts up, cuts right off. Now you're thinking, well, maybe there's some debris in the fuel lines, we got trash, it's got a metal tank, you can see the rust scaling in the bottom after we got the fuel out of there. All right, so now you're thinking it's still a fuel problem. All right, okay, here's what the plan is. So we come over here, we go to the supply line that's going up here to the fuel rail. All right, so you get a quick connect, come in the back, pull it out. All right, now we get a mason jar, good old big mason jar. We take the fuel line, we put it in there, we prime it. Big stream of fuel comes out. All right, turn it over to crank, let it crank, and I mean it's a steady stream coming out of there. Looks good. It's a nice geyser. All right, we fill the jar up, looks good. Remember, this is our good fuel. We set it. All right, we want to see if there's any rust particles in there. Set it a few minutes, look at it, looks great. And you're thinking, what in the hell? We got the fuel. All right, so now you're still convinced it's a fuel problem. All right, so maybe the injectors are somewhat stopped up. Maybe some of this debris got up in there. Because they've been trying to crank this engine over the years. Nobody could figure out how to get this thing running. There've been to 2 other, shops. Mechanics didn't know what the hell to do, right? In fact, they come in here, and I don't know if these orange connectors are probably fuel injectors or the Ford, but I see it's like black. But anyway, we got orange fuel injectors. All right, so you're thinking that, and look at here. Look at all of these ignition coils. They have changed every friggin' ignition coil on here. That's not the factory ones. The factory ones are in the trunk. So if somebody's getting real desperate here to try to get this thing to run, well, it turns out, okay, let's check the fuel injectors. I check them, I put them on a scope, look at the waveform, looks good to me. All right, so let's do a fuel pressure drop. So go to each injector, do a fuel pressure drop, and you put the injector pulse tester on there. Look at the before pressure. Every one within a pound, no more than a pound difference. Now you think, what in the hell? This thing is getting fuel. You getting the spark? Oh yeah, we checked the spark. Make sure we did on like 3 coils. Check it over here, over here. That looks good. How come this thing ain't starting? You know, it's staying running. It'll start and it'll run for about 1 second. Then, okay. Now here's where our issue was at. So we take off the air intake tube. All right. And what do? We look in here. Now you look, everything looks good in the box. In the air box, filter's good. And then you take this here air intake tube and look, and what do you see? When you're looking through, you see that the mass airflow sensor has dirt daubers. You know, there's a little dirt, and it's like just about like a freaking little bit of concrete. This here sensor was totally encapsulated about this thick, totally around the sensor of where these here dirt daublers got in there and built this here, you know, this here mud that just covered the whole entire sensor. I mean, I've never seen anything that bad as being dirty. All right, so as a quick check, we take this connector and we unplug it. Go to the car, turn it over. That joker started up right away, and it stayed running. Okay, take the mass airflow sensor out. So we get some cleaner. I have a small pick, and I'm just kind of wetting it, kind of softening up that material, you know, the dirt daublers made, and just picking this out. That took 40 minutes to clean this joker, because I'm trying to be as careful as I can, because you know the sensors in there is very fragile, and I don't want to get a pick in there, because you don't know exactly, you know about where it's at, but you don't know exactly where it's at, and you don't want to go in there and poke him with a pick, and then the next thing you know, now you've damaged this mass airflow sensor. And you know what, I'll put one in, I want to get an OEM. Well, you don't want to spend like $300. So anyway, it took like 40 minutes to clean that joker, put it back together, started right up. Everything looks good. Looked at the on the scanner, we got about 4.3. This is a 4.6 liter engine. So we had about 4.3 grams of air per second. Now I'm thinking, here's what I'm thinking now. The air is coming in, so the dirt daublers can come in through the fresh air intake. Well, look at here. It goes in, in, in. Well, the throttle valve is closed, so I ain't too worried about getting in there. But look at here. There's 2 breather hoses on the back, over here on the back of this intake. So they could come in here and make a nest. Well, they could come down in here in this hose right here and make a nest. So while this is off, I pull this hose off, pull this hose off. Guess what? Both of them totally blocked with dirt daubler nests. So that hose was blocked, right? This hose here was blocked right in here. And this hose down here was blocked right up in here. So I had to dig that stuff out with the pick. So I think we're in pretty good shape. The engine runs good, it's quiet. The only other issue now that we have to work on, and we have to do a diagnosis on it. If you take a look back here, now this car, if you look back here, you can see that the rear is too low. Now anybody that's familiar with this vehicle, you know, the Marquis, the Murata, and the Lincoln, they have this air suspension, right? Well, they have these air springs that's sitting right up on top of the axle, on the rear axle. So you have one on each side, basically like an air bladder. And then you got a air compressor. And what happened is air compressor, which is located up here, and we have not looked at this. I don't know, have no idea what's wrong with it. I do know that the air compressor is not running. Could be a bad fuse, bad relay, who knows. But anyway, the air compressor sits right down up under here, right up under the air box. Okay? And I'm just looking. This is the first time I'm actually looking at it, but from what I've seen, I'm thinking it's supposed to be under there, but actually, no, I don't see it. Anyway, maybe it's a different location. But the point is, I have to look at that, see what's going on with this. And these air bladders back here, of course, sitting for all these years, that means these air bladders, looking at them, the rubber on it, you can tell it's just totally dry rotted. It is cracks all over it. So even we get the air compressor running, I'm pretty sure that we're going to have an issue with the, leaks on that. So I already suspect the air spring is going to have to be replaced. Anyway, it's an ongoing thing, and I've been here 4 days. We'll be doing some other stuff too, not just the fuel system, but other little stuff, fluids and coolants. And this was low, so we went to Ford dealership. We got some antifreeze. We topped that off and made sure the oil level's good. EGR valve here, assembly, we checked all that. Made sure electrically it's working and the valve is working good, so that's all good. The DPFE sensor is working good. Oh, and the air conditioner, surprisingly, the air conditioner works. It blows out nice cold air, so that's one thing we don't have to worry about. Anyway, guys, I know I've rambled on, but I just wanted to let you know what the issue was. But fuel pump was definitely bad, because before it would not even prime. You couldn't hear it, but now when you turn it switch to on, you could definitely hear it prime for about 1 second. What?
Fuel filter.
Oh yeah, I already mentioned we changed the fuel filter, because the thing sits that long, you definitely going to be changing the fuel filter. So that was changed also. So if I do anything else more to this car, I'll do another little video, but I'm hoping my brother here can wrap it up, so I'll do the diagnosis tomorrow on the air suspension and tell him, hey, change this part or this part, whatever you need to do. And I'm definitely sure it's going to be the air spring's got to be replaced, because like I said, the rubber on it just totally dry rotted. Anyway, that's where we at with it. I didn't want to leave you guys hanging to just show you that part. What?
You want to start it up?
Oh yeah, go ahead. I'll let my brother go ahead and crank it up, and I mean, hell, I could be out here bullshitting you guys, huh? So go ahead and crank it up. That sounds pretty good. No ticks, valve sounds good, no knocking. Now, as time goes on, you're driving the car a little bit, of course, some other issues might pop up. As far as looking at the engine, the sensors, the injectors, the coils, all that, it sounds pretty good. All right, guys, that's it for now, so we'll catch you in the next video. You guys take care.